What is the Monte Carlo process?
The Monte Carlo process is a simulation technique that is used to statistically predict the duration of a project when there is uncertainty about the duration of the activities of the project. Simulation techniques are used because the number of simultaneous algebraic equations would become quite large even for small projects. PERT analysis of project schedules allows for there to be uncertainty in the durations of the project activities. In the PERT analysis, however, the critical path is usually held as a constant set of activities. In reality, the critical path may actually be different from one set of project activity durations to another. In the Monte Carlo process, a duration is selected from the possible durations for each activity in the schedule. The project schedule and the finish date for the project are calculated. Once the project completion date is calculated and recorded, a new set of dates is picked for the activities in the project, and the next project finish date is calculated and saved. This process is repeated enough times to become stable, usually about 1,000 times, and the statistics are calculated. The most important statistics are the probability of the projects finishing on certain dates. Tell me more. The Monte Carlo process is used in project schedules to help predict project completion dates when there is uncertainty in the durations of the project activities. The problem with using uncertainty in project durations is the effect these uncertain durations have on the predicted project completion date. Since the completion date of the project is determined by the length of time contained in the critical path, it is important that we know what the critical path is. If there is uncertainty in the durations of the project activities, it simply means that the critical path could be one sequence of activities for one set of durations and a different sequence of activities for another set of durations. It would be incorrect, for example, to predict the completion date of the project by using one set of durations when another set of durations might yield a different critical path and a different project completion date. The prediction of the critical path for the project when there is uncertainty in the activity's durations can be quite difficult. It would take an impossibly large set of simultaneous equations to analyze the possible critical paths of a project, predict the probability of each occurring, and then calculate the duration of the project. For this reason, a simulation method is used instead. This is the Monte Carlo process. The first things we need to consider in the Monte Carlo process are the durations of the project activities. Since we are considering the use of the Monte Carlo process in the first place, we are recognizing that there is uncertainty in the durations of the project activities. If the durations were known, we would not need a statistical technique at all. But how do the durations vary? We can think of this variation of durations as a probability distribution. In Figure 5.23, the probability distribution relates a given duration to a probability of its occurring. The even distribution says that the probability of one duration's occurring is the same as the probability of the occurrence of any other duration in the range of possible values. The triangular distribution says that the probability of any durations occurring increases in a linear way from some minimum value until a value for the most likely duration is reached. At that point, the probability decreases linearly until the highest value of duration is reached. The familiar normal distribution says that the relationship between the duration value and the probability is similar to a normal distribution. In any Monte Carlo simulator, there will be many choices given for probability distributions. The distributions given here are only 3 of many that can be selected for the project activities. Since Monte Carlo simulations must be done on a computer, we will be using software designed to do this process. The software will make available a wide choice of distributions. Figure 5.23. Probability distributions. Once we have assigned a probability distribution to each of the activities in the project, the computer will do most of the work for us. It will select a duration for each activity in such a way that the combinations of different durations for the different activities is random, but they also fit the probability distribution we have specified. Each time a set of durations has been selected, the critical path schedule and the project completion date will be calculated. Figure 524 shows a random number table. In the old days before computers, engineers and mathematicians would use tables like this one to generate random numbers. Random numbers are actually quite difficult to calculate because a truly random number has exactly the same probability of occurring as any other random number. In other words, random numbers are the ultimate even distribution. Any number at all has exactly the same likelihood of being the next number in a series of numbers. If we were using two-digit random numbers and started with 56, any number in the range of numbers from 00 to 99 would have exactly the same probability of occurring.